So we took care of derivatives and integrals of natural log. Let's take a look at derivatives and integrals of e to the x. If I want the derivative here of e to the x, guess what that is? E to the x. What? Yes, that's real. So if my derivative is e to the x, if I want to integrate e to the x dx, what do you think you get? Yeah, you do. E to the x plus c. That is why on that last video I said anytime you can put this in terms of e, you want to. Because the derivative of e to the x is e to the x. The antiderivative, same thing. It's awesome. Okay. Let's do this. Let's take some derivatives here out of example 3. I have part A. Y is equal to 3e to the 2x minus 4e to the x plus e to the negative 3x. Yeah, this is just a polynomial. So y prime, notation, right? So the coefficient's still just the coefficient. E to the 2x times the chain rule. Oops. You still multiply by the derivative of the inside function, and the inside function for us here is a 2x, right? Minus 4e to the x, because the derivative of e to the x is e to the x, plus e to the negative 3x, again with the chain rule, the derivative of the inside function is negative 3. Clean that up and we'll call it good. 6e to the 2x minus 4e to the x minus 3e to the negative 3x. And that's it. Pretty cool, right? Let's do some more. Let's do more. I love that. Here we are. Y is equal to e to the p over e to the 2p minus 1. What do we get to do? Yes, we do. Quotient rule. Exactly what we get to do. Good. So this is nice. Look at this. We've practiced the product rule. We're practicing the quotient rule. Wow, this is your best day ever. Let's do this thing. So the derivative of the top, because the derivative of e to the p or whatever variable you use is still e to the p. Oh my. So e to the p, derivative of the top times the bottom, minus the top times the derivative of the bottom. Now, we've done this once or twice, so I'm just going to go with it. You know when you have to chain that, so you get your e to the 2p, and then the chain rule is times 2. You see that? So e to the 2p is exactly what it is, times the chain rule, because the derivative of that is just the 2. That's where the 2 comes from. All over the denominator squared. All right? Now, let's clean this up a little bit. When you do math and you try to clean this stuff up, I always try to look a step ahead. That's where your trig, remember in trig when you did those identities, you had to make one side look like the other? This is what's super helpful. So, oops, I'm going to do this. If you distribute here and you multiply this, notice you're going to end up with, scoot this up just a little bit here, like terms. So, like bases, you add the exponents. So 1p plus 2p is 3p's minus e to the p. Again, 1p plus 2p's is going to be 3p's. And now you have like terms. So combine your like terms. And I'm going to factor out a negative just because it makes me... Oh, we could even do more than that, couldn't we? Oh, check this out. So I have negative e to the p minus, how many we have there? E to the 3p. all over e to the 2p minus 1 squared. So you could factor out just a negative. Oops, that makes that a plus. All over e to the 2p minus 1 squared. Or, if you want to get extra fancy with it, you could say factor out this negative e to the p, and you're left with 1 plus e to the 2p over the same thing. Not plus, it's a minus. In my head, and I was just thinking, oh, if that was plus, that'd be awesome. And so power of suggestion there, right? Because it would be awesome, right? If you factor that out, and this would have been 1 plus e to the 2p and 1 plus e to the 2p down here, you could cancel one out. But it's not. This is a minus sign. This is a plus sign, so you can't cancel those. But those are things to be thinking about while you're working these problems. Is there something you can do to cancel, simplify, make this look nicer? That's what you're looking for there. All right? Okay, let's do some more. Here's example 5. We're going to integrate. So I have part A here is e to the 10x dx. All right. We're going to work this two ways. The first time we work this, I'm going to show you the long way to do it, but you're in Calc 2 now. The way that I show you second to do this, you can get to this in one step. You should be able to look at this and tell me the answer, all right? And we're going to do the long way in order to prove why that's the case. So here, I'm going to do a u sub where my u is equal to 10x, which means my du is equal to 10 dx, right? Here's the deal. Anytime you have this oopsie daisy, I wanted this. Anytime you have just a number here, 1/10 du is equal to dx. If your du equals your dx, then you should be able to go directly to the answer. All right? Okay. So I'm going to pull this 1/10 out front, and I have e to the u du. So we know the antiderivative is still the same. So this is e to the u plus c, and then we u sub back in e to the 10x plus c. Right? Now, here's what I expect you to be able to do. If you have this integral of e to the 10x dx, as soon as you know your du is equal to your dx and you just have this 10 up here, we're basically just doing the reverse chain rule. Instead of multiplying by 10, we divide by that 10. So I really have 1/10 e to the 10x plus c. All right? Now you're in Calc 2. We're going to be looking at more shortcuts, and we're going to shore this up, right? The goal is efficiency. I want you to be efficient with your math. And this is one instance you can do it. Now, you can't do it all the time. But if it's just a number in there, then you can be efficient and knock that out. Okay? When you get comfortable with it, if you still want to go the u sub for a little bit, you can. But I'm going to be pushing you, push, so that you can be more efficient. Math is not your end game. It's a means to the end. So you want to be efficient with your math so you can spend your time doing the content otherwise. Okay, let's take a look at this one. I want to integrate e to the x over 1 plus e to the x dx. Now here's a situation where we can't do that, right? I have a rational function. There is no such thing as a quotient rule when you integrate. U sub is your go-to method. Once we get into chapter 8, which is all about integration, we'll have a different conversation. But for now, it's either direct integration or u sub. So remember, with your u, you want to go for the craziest thing. So that's my denominator. The derivative of a constant is just 0. The derivative of e to the x is e to the x. And don't forget your differential. Now I'm subbing out e to the x dx, subs directly out. It's called a u substitution, so use your substitution there. 1 over u du. Look familiar? Oh, yeah, it does. That's my natural log. I told you that fellow wasn't going away. Natural log of u. Just learned it. And then you sub it back in. The natural log of 1 plus e to the x plus c. Which is why I always make my absolutes dark, because I don't want you to think it's a 1. That's just my way of trying to organize our work a little bit better. Cool, right? It's coming along.